My name is Matteo Luccio. I'm the editor-in-chief of GPS World. We are at the Institute of Navigation Joint Navigation Conference in San Diego. I'm with Roger Hart, head of engineering, and Jeff Martin, head of sales at Spire and Federal. And we're going to talk about complementary PNT and how simulation plays into that. So, Roger, there is much talk about the vulnerabilities of GNSS and the need to develop complementary sources of PNT. So what are some of the most promising approaches, and how does simulation technology help?
Okay, well, thanks for the chance to talk with you today, Matteo. It has been a big topic here at the JNC. Definitely the vulnerabilities of GNSS systems have been recognized. The national systems, the legacy GNSS systems, are all operating on pretty much the same frequencies and the same power levels. So together they have been recognized as having some significant vulnerabilities that can affect all of them together. So there have been great interest in finding ways to complement that or even replace those capabilities. Some of the long-term ones, you've got there's the dead reckoning and magnetic and inertial systems that have been around for a long time. Emerging more have been the alternative radio frequency. Making use of those for navigation. Some of them are communications that we're piggybacking and deriving PNT from. Others are intended for new PNT systems specifically. So a couple that we've been focusing on are the alternative navigation systems. They may be using different orbits, different frequencies, different encoding schemes that set themselves apart from the legacy GNSS systems, and so that they will use together provide a greater resiliency, so that they can even stand alone when one or the other system may be affected by interference. Not to be forgotten, as I mentioned, is the inertial navigation. It's been around for a long time. It's still a standard of navigation, and it, together with GNSS, makes a terrific navigation system. It almost defines complementary. So where GPS is vulnerable, inertial can fill in the gaps. Where inertial drifts, GPS doesn't, and paired together, they make a very, very strong system. So at Spirent, we've been working with customers to provide a variety of options for both those alternative navigation systems and inertial. So it's both of them are very active fields of development, and we're keeping abreast of that.
Yeah, some good points, Raj. This is something we've been engaged in for quite a long time. Since we provide test equipment to the community, it's critical that we try and understand what they're worried about, what the vulnerabilities are. So it keeps things exciting, keeps us on our toes, and keeps us looking ahead to what's coming.
So let's drill down a little bit more, specifically with the GNSS INS integration. What are some of the remaining challenges of integrating GNSS receivers with inertial sensors, and again, how does simulation technology help with that?
Okay. So inertial works by integrating sensor measurements that come in. So any errors that are on top of that just accumulate over time and can corrupt and take off your navigation solution for poor accuracy. So there's a strong focus on updating error models, and not only updating them for the scientist, only those that understand what they mean, but translating those so that the everyday user is able to make use of those error models and get good real-life type performance from that. Also, there's a tendency to think of integrated GPS, INS, as putting everything together in one box. And there are packages that do that. The model now and the push is to go to more distributed systems where they are, in fact, integrated, but not packaged in the same box. One example of that is the all-source position and navigation standard that's being developed and pushed in the DoD that will allow you to swap out one, as long as they adhere to the standard, swap out one sensor for another, and that information all goes back to a sensor fusion engine, and you can do your navigation that way. So we've been had for years Ethernet connections, the ability to model the actual sensor electronics outputs in there, and we're working with the Aspen standard to expand that portfolio of ways of communicating inertial information.
Yeah, this is a field we've been in for a long time. So GNSS simulators are something we've been well known for about 4 decades. Inertial, we've been playing that sandbox for at least a couple decades as well. So it's given us the opportunity to have relationships with the key manufacturers and designers of inertial systems. That same sort of model or plan of having those relationships it's been expanding well beyond inertial. So lots of other sensors and systems that are now kind of coming online or have been being worked for a little while are something we've been keeping ourselves abreast of and forging new relationships with new folks. So it's been exciting.
So one enduring challenge is urban canyons. A lot of work has gone into addressing that challenge. So how does simulation technology help?
Okay, yeah, urban canyons are kind of your worst nightmare for GNSS signals. If you're surrounded by tall buildings, signals are blocked, so you may have few or no even satellites in direct line of sight. And what you do get are reflections or multiple reflections even of multipath. So diminished and corrupted signals are available to you. So emerging alternatives to that are complements to it. Of course, you know, the more GNSS satellites you have, the better chance you've got of getting some direct line or good signals. But complementing that is the radar systems, vision systems, and I think those are the ones that are really going to stand out. Maybe particularly the vision systems that can read the street signs, see what the curb is, look for parked cars, all that kind of thing will really help fill in when you've got poor GNSS coverage. There's kind of 3 areas that you can focus on in terms of simulation and dealing with those. You can observe what's going on in the environment, and then we've got capability to simulate that environment. And then finally, we've got the forecasting tool that can help you look ahead to that. I don't know if Jeff, you want to say any more on that?
Yeah, this is where things kind of get exciting, isn't it? Lots of areas where they get exciting, but these environments where GNSS is contested, it gives us a lot to do and help the industry with as simulator manufacturers. Terrible to be in an environment, whether it's an urban environment or an environment with intentional jamming or something scary. To be in that situation in real life is bad news. To create that in a controlled environment in the laboratory is great. You can pick things apart. You can see you can see where you need to improve, and you can create that scary environment in a safe, controlled space. So I get excited about it. It's probably the geek in me, but it's good stuff. It gives us a lot to look forward to, and gives a lot to our partners who are out there actually doing this.
A lot of work is going into using LEO, that's low Earth orbit satellites, whether piggybacking on the Iridium satellites or launching new satellites and so forth. So how does simulation help with that effort?
Well, certainly in the development of the systems, the receivers, the groups that are using these alternative RF and LEO, MEO systems are needing simulation as they develop their systems, as they develop the receivers. It gives you the ability to try things, certainly before you launch them. And what we've seen at the conference is there is considerable interest in making things reprogrammable. We've got the NTS-3 satellite that's going to be running experiments for different waveforms that can be generated. Even M-code is kind of a step in the direction of giving more flexibility to the signal. It's got a lot more flexible cryptography and signal generation than you had with the legacy CA and PY codes. In simulation, our platforms are software-based, and so we can generate and receive IQ data that can be useful for the software-defined receivers in their developments. It's kind of a playground that gives you the opportunity to try different waveforms, and so I think we're well positioned to meet the needs of
No pun intended.
yeah. So we've already delivered one that's a satellite-based alternative navigation system simulator, and we can build on that one as to service the other LEO constellations as they come forward.
And Roger mentioned MEO, which is medium Earth orbit, and then there's geostationary. Jeff, anything to add?
No, Roger put it well. I think this is where things get fun. People are concerned with vulnerabilities to PNT. So we're seeing these great new things, these alternative signals, alternative navigation solutions coming forward. Spirent has done a good job over its nearly 40 years of existence of manufacturing and designing its own hardware and software. So it's given us the opportunity to respond quickly. These things are coming fast. People need solutions quickly. And as Roger said, we've got some solutions we've pushed out the door, and the platform upon which we've created that gives us the flexibility to continue doing it. We're seeing more and more ideas come to fruition, and people need to test. So this is where it gets fun.
So you mentioned a variety of sensors, and so sensor fusion brings it all together. So again, how does simulation technology help with that effort?
Well, it definitely helps. You've got to put all the pieces together, and you can't know how your system is going to work by individually testing each piece. You need to be system is the key word here. And so in simulation, you can generate the signals, the messages, and all that, and bring it in together into a sensor fusion engine. You can test different algorithms. It's certainly much cheaper and quicker than trying to build this into a product and then test it. So simulation has, over the decades, proved itself as a very valuable way in both basic development and integrating the final product.
Through production test. So totally agree with what Roger said, all the way through. It's a lot to consider and a lot to take in, but that system-wide fusion is where the magic happens.
Well, great. So it sounds like simulation technology and Spirent Federal in particular are very much at the center of a lot of the current developments and discussions about complementary PNT. And any final comments?
Well, as Jeff said, it's an exciting time. There's a lot of things going on, new technologies, new way of communicating. And so it's a busy time and a bit of a scramble sometimes to keep up with all the new things that are coming.
Okay.
I think you put it well, Matteo. I think people do look at Spirent to be their testing resource, and it does put us right in the mix of it. And we're excited to be here and happy to have met with you.
Well, thanks again, Roger and Jeff. And again, From the Joint Navigation Conference in San Diego, this is Matteo Luccio, Editor-in-Chief of GPS World.